This is the kind of triangle that we want to solve today. And this is different than the triangles we were solving the other day. Remember we were doing SOHCAHTOA and the Pythagorean theorem? What kind of triangles were we using at that time? Right triangles. The fact is that there's all sorts of triangles, right? And most of them are not right triangles, they're wrong triangles. And so as we look at this one, there's no 90-degree angle. And so we're going to label A, B, and C. And we would like to be able to solve it. And so we want to find a relationship that exists that we can solve it. Do you remember what we called this side here? This is side C. How about this one? This is A, and then this one is B. So the opposite side takes on the lowercase letter, right? Exactly. So here's the relationship that exists. It's very helpful in trigonometry if we know an angle and its opposite side. An angle and its opposite side. An angle and its opposite side. Because, and I won't prove it for you, if you'd like to see it, I'll do it. We just don't have a lot of time. Turns out that if you take the sine of an angle, like angle A, and divide it by its opposite side, side A, turns out that that is equal to the sine of angle B divided by its opposite side, side B, which is equal to the sine of angle C divided by its opposite side, which is side C. So it's a really nice formula. It kind of just rolls off your tongue. Sine of A over A is sine of B over B is sine of C over C. So if you have a right triangle, you use SOHCAHTOA. But actually, this works for any triangle. It also works for right triangles. Any triangle you want. It's beautiful. That's our goal today. We're going to solve two triangles to kind of prepare you for what you're going to do. Instead of doing these two, let's do the two that are on your worksheet and get you started there. So take out your worksheet. Supposed to get a little snow tonight. About an inch between this afternoon and tomorrow morning. Super cold weekend, but it'll warm up later on. Here we are, the basics of the law of sines. We start by just drawing a triangle, and it doesn't matter where you put A, B, or C. A is 85 degrees, B is 32 degrees. And it says side B is 20. Make sure that you label the triangle appropriately. I think we've all kind of gone through that part of labeling it. I have 6 pieces I need to find. How many of them are given to me? There are 3. Angle A is 85 degrees. Angle B is 32 degrees. And side B is 20. I now need to figure out the other 3. What is the easiest one to figure out up here? Angle C, because all the angles add to 180 degrees. So I go ahead, take out my handy dandy calculator, and take 180. I subtract off 85, and I subtract off 32. And I get 63 degrees. Any question thus far? Then if I would like to find a side, Jonathan, would you like to find side A or side C? He wants to find side A. So we're going to set up an angle and its opposite side. Which angle do I have that has its opposite side given to me? That's what's crucial, is that you recognize I got an angle on its opposite side. So I set that up. Sine of 32 divided by 20 is equal to, and then Jonathan said he would like to find side A. So therefore I do the sine of what? I have to choose 85. I have to choose angle A. 85 divided by side A. Couldn't you see how confusing it would be instead of like sine of A, instead of sine of A over A, if it was like sine of A over B, like try to remember where the letters went. But it's really nice that the angle matches with the side. So this is what we want to do. We want to solve this. There's multiple ways of doing it. If you've got a way, good for you. I'm going to turn these top two pieces, sine of 32 and sine of 85, I'm just going to turn them into decimals, and I'm going to cross multiply. Seems like that's the way that a lot of people like to do it. So I'm going to go sine of 32, and when I take the sine or tangent or cotangent, so I always write it out to 4 decimal places. So 0.5299 over 20 is equal to, and we'll do the sine of 85, which is 0.9962 divided by A. Now, I think everybody here remembers how to cross multiply, right? So we're going to take 20 times the 0.9962, and then we're going to divide by the 0.5299, right? So I'll multiply, and then I'll divide by the 0.5. So let's do that. We got 20 times 0.9962 divided by 0.5299. And what do I get? I get 37.60, we'll call it. So 37.60. There's something important there. When I get that 37, I don't know about you, but I start to wonder, is that even close? How does angle A compare to the other angles? It's the biggest angle. So far, is that the biggest side? Yeah, it is. The biggest angle should correspond to the biggest side, and the smallest angle should correspond to the smallest side. If I don't have C, then I just use the Pythagorean theorem, right? Pythagorean theorem applies to what kind of triangles? Right triangles. Is this a right triangle? It is not. So the Pythagorean theorem does not apply in this situation. So we just use the law of sines again. And you have 2 choices. You can do sine of A over A, or you can do sine of B over B. It doesn't matter. I'm going to do sine of B over B again. Sine of 32 divided by 20 is equal to sine of what? What do I choose now? 63 divided by C. And I'm going to go ahead and make those into decimals. So I'll do, let's see, sine of 32. We already know that one. That was 0.5299 divided by 20 was equal to, and I'll do sine of 63. Sine of 63 is 0.8910 divided by C. I'm going to cross multiply. 20 times 0.8910, and I'll divide that by 0.5299. And I get 33.63. That's in between the 20 and the 37. And that makes sense because 63 is between 85 and 32. Not too bad, huh? Law of sines. This is one of those where I do expect, I mean, that's just my expectation. I expect every single person on the test to get this 100% correct. I think everybody is capable of doing that. Now, we all know people make small mistakes here and there, and I understand that, but this is very, very doable. So this actually has potential to be a great scoring test for a lot of people, which is always good news. Let's try the other example, and then we'll let you guys work. Example 2, we know that A is 40 degrees. Side A is 10 and side C is 7. Can somebody please tell me what's different about this problem compared to the first one we did? 2 sides instead of 2 angles. So we can't just come up with the other angle, right? I mean, we've got 2 of them. So there's no easy, like, just subtract from 180 right now. And you can't use the Pythagorean theorem to come up with side B. But you can just use the law of sines. Watch how we set it up. We have an angle and its opposite side. Again, angle and its opposite side says use the law of sines. Sine of 40 divided by 10. Equals the sine of what over what? Sine of C over? Yeah, see, because I have side 7, I'm going to use that to get my angle C. So I'm actually, we'll figure out a decimal for sine of 40. Sorry, I was just trying to figure out the best way that I thought would work for you all. Sine of 40, and I get 0.6427. 0.6428, we'll say. Divided by 10 equals sine of C over 7. Can everybody see that? I'm not going to talk about cross multiplying a situation so much as I'm just going to multiply each side by 7. And then I'll just have sine of C over there. So if I go 0.6427 and I divide it by 10, and then I multiply it by 7, I get 0.44995. So 0.4499 is equal to sine of C. So on one side I have the decimal, on the other side I have sine of C. Does anybody remember what we press on our calculator if we're looking for an angle? Second sine. So when you're looking for an angle, you don't press sine, you press second sine, sine inverse. And we type in the decimal, 0.4499. And it gives us 26.74. And folks, I'm not, if you're off by 100th, I'm not that concerned, okay? If you're off by a degree, that's definitely a concern. Okay, so now what? What's the easiest spot to find now? Angle B, right? Because I can't find side B until I find angle B. And angle B is now easy because these all add to 180. So I take 180, I subtract 40, and I subtract 26.74. I get 113.26. Well, now I can set up my law of sines again. And I like to stay with what I did before. Sine of 40 over 10 is equal to sine of what over what? Yeah, I have to choose angle B because I want to find side B. And I know what the sine of 40 is. We found that right over here. It's 0.6428. But I don't know the sine of 113.26 yet. I'm going to have to press sine of that guy to see what I get. I get 0.9187. And now I'll cross multiply. So 10 times 0.9187. I'm going to divide by 0.6428. 14.29. That's a lot bigger. It's more than twice side C. Is that okay? Yeah, because angle B was by far the largest angle, so side B is going to be the largest side. What do you think? Not too bad, huh? No. Part of what I like about this so much is that this is something that's new to you. And you get used to your whole life in math, often solving 2x plus 1 equals 9, or, you know, learning to deal with fractions, right? And so you finally see something that's new. And it's interesting. There's a lot of interesting mathematics out there that you haven't seen yet. What do I expect you to do for your assignment? Do problem 1 and 2, 3 and 4. As you flip it over, do problem 5 and 6. You don't have to do problem 7, 8, 9, and 10. That would be up to you. If you would like extra practice, go ahead. But just do those 6. Please understand that all of the problems on the left, or all the problems that are like problem 1, the odds, they're all like this guy, where you're given 2 angles. All the problems over here, so I have 3 of them where you are given just 1 angle and 2 sides. And that's how it's broken down. So this is your 3rd lesson. You'll have 1 more lesson, and then we'll get ready to test on these ideas. Okay?